Hello everybody and welcome to this session. My name is Nick Jastrzewski. I'm a consultant here at the Information Lab and I'm going to be running this session on setting up an external repository for Tableau Server in AWS. So what we're going to be covering in this session, we're going to have a bit of a recap first of all and talk about what exactly the Tableau Server repository is. And then we'll go through and talk about why you would even want to externalize that repository. We'll also cover the requirements for setting up the repository itself, the options that you have available for the external repository. We'll go into a bit of discussion about what you need to consider when choosing between the various different options. And then we'll go through and actually show you how to set this up on a Tableau server itself. And then at the very end, we'll have a little bit of a looking ahead and talk about what is coming up in the future. So, first of all, what is the Tableau Server repository? It is a process within the Tableau Server, so the server itself is a collection of various different processes that all work together to create the final product that you see when you log into the browser. The repository is just one of these many processes, and you can see it over there on the left-hand side, the big green icon there towards the bottom. The repository is a core part of the server that is required for it to work, and it is essentially the place where the server will store all the information about what's happening on the server. So all your users, all your workbooks, data sources, extract refreshes, everything that you can possibly imagine is all stored there in the repository. Literally every activity, so even somebody who's logging into the server, that gets recorded. This is needed because the Tableau server needs to not only record the activity that's happening, but also query that database to understand who should have access to things and who shouldn't have access to things. That means it is essentially a database. So it is based on PostgreSQL, and that is the underlying architecture of the database itself. This is what is used by the inbuilt administrative views in Tableau Server, but you can also query it yourself, so you can connect to the database directly and build your own custom views as well. So that is essentially what the repository is. So why would we want to externalize the repository? So you can see over there on the left hand side, this is what we will see at the end of today's session. We will see our repository was then moved over from our primary Tableau server node onto an external node. So why would we want to do that? Well, there's a few different reasons depending on your use case. For one, it can improve the performance not only of your server itself but also of the database. The two are kind of linked in a way. So an inbuilt repository that's built into the Tableau server, that is going to share the processing power with all of the other processes that are going on. So you can see in that list there, all of those green ticks are a different process. All of those require some sort of processing power to run. So if that is inbuilt within the server itself, it's going to be sharing all of that hardware with all of the other processes. So your backgrounders and your VSQL servers, they're normally the ones that are competing for resources, but if the Postgres is also having to capture lots of activity that's happening all at the same time, that can take up quite a lot of processing power as well. So by externalizing that, we can give our database dedicated hardware to run on, so that helps improve your database's performance, because obviously it's got its own machine, it's running on its own hardware, it's not having to share anything, but it also means that your Tableau server itself isn't having to spend resources on the Postgres database. So you're just completely separating the two and sort of essentially giving your server more space to run and make sure that it is running as effectively as possible. Another reason why you might want to do this is to ensure high availability. If you have an internal Postgres only, there are options for failover. So if one of your server nodes goes down, you can set up a failover to a secondary node with an active and a passive repository. But you are kind of limited as to how you can set this up. It's a bit of a sort of black box. There's not really that much configuration you can do on how it's going to handle that failover. You just kind of need the two nodes there for the failover to happen across, and it also requires a multi-node server cluster. If you're going for high availability, you will probably have a server node cluster anyway, rather than a single node, but you are kind of limited by the scope of how you can set up the repository with only really the two, active and passive. You can't build any more backups beyond that. With an external node, with your repo externalized, you have complete control over how many nodes you want to spread that across, how you want to handle any sort of failover across the various different databases. It's all under your control, so you can ensure that no matter what happens with your databases, you are always going to end up with a server that is up and running. Even if 3 of your nodes might go down, if you've got another one that can pick up the slack, then you're fine. But that means that you're again linked back to performance. You're only relying on those machines to run the database, whereas with an internal repository, if your primary node goes down where your active repository is, you're also losing all of those other processes as well. So you've got more dependency on the machines that the Tableau server itself is running on. By spreading this across more machines, more servers, you're having less chance that your server is going to fall over, because if one machine drops, you've got plenty of others to pick up the slack. Lastly, kind of related to performance in some way, by externalizing your repository, you can make it easier to keep your old data archived. So best practice with your internal repository would be to run server cleanup processes roughly every week or so to clean out old data that is stored in the Postgres repository. There is a particular table in there, which is the HTTP requests table. This can balloon out to very large size because, as I mentioned earlier, every single request that's being sent to the server is being recorded. So when you run a server cleanup, it's going to get rid of older data. That's by design, because it essentially keeps your Postgres repository running smoothly and keeping it lean and running nice and fast without storing loads of data in there. But if you move this repository off to another node, you're not having to worry about that, because the database itself can handle having more data in it, because it's got that extra hardware, it's got that dedicated resource to handle all of this. So you can store that in your external repository, and then your Tableau server isn't going to balloon out with the storage that it's having to hold with all your old data. It's not having to worry about any of that. Your dedicated standalone database can handle it. There are other ways that you could set that up as well. So you could have a small, lean, active repository, as it were, on an external node that is running the same way as you might with an internal one, cleaning up every week, making sure that it's running nice and smooth. And then linked to that, you could be taking snapshots yourself and storing all of that old data in just a standalone database somewhere else. It's much easier to do that with an external database versus the internal one in that you have within Tableau Server, because you can just set up automatic replication from, say, an RDS instance to another one, and it will just store all of your old data nice and easy. So that way you can keep your data archive and you can keep records of everything that's happening on your server going back for years without impacting on the server's performance. So what do you need to actually set this up? Obviously you need Tableau Server, that's kind of a given, but the version that you have of Tableau Server is going to depend a little bit on how you set this up. So if you want to have an AWS-managed solution for your external repository, you will need at least Tableau Server version 2019.3. If you, however, want to use your own database and set it up yourself, you will need at least version 2021.2. So it's a relatively recent addition. Earlier this year in 2021, they added the option to be able to set up your own Postgres database on any machine. So fire up an EC2 instance, install Postgres, and use that as your external repository. Or you can also do it in-house, so you can have your own on-premise machine running a Postgres database. As long as your Tableau server can communicate with that, you can set that up as well. But as I say, you need version 2021.2 or later. You also need the server management add-on package. Without that, you can't set up an external repository. So when you license the Tableau server, you need a key that includes the server management add-on. And lastly, you do actually need some sort of external Postgres SQL database. We'll go through the options that you have for that database in a moment, but these are the fundamental requirements that you have. So in terms of the database that you're going to set up, when we're talking about setting this up in AWS, we have three main options to choose from as of 2021.2. We have RDS, we have Aurora as well, which is a slightly different engine within RDS, but then we also have that EC2 instance that we can set up with a standalone Postgres installation. This, as I say, is new in 2021.2. So we're going to focus on that in this session today. So when you're choosing between those three options, there are a few things that you need to consider. These are the main ones that I would probably point you towards. The administration overhead of setting up each of these. Version compatibility is an important consideration. We then have the usual considerations of scalability and redundancy, and then of course cost can be a big factor as well. So let's go through each of these and talk about them in a bit of detail. So in terms of administration, as you might imagine, an AWS-managed solution is pretty much the best option between the two here. You're going to have minimal requirements for administering the system. All of your minor update versions are going to be automatic. You don't have to worry about managing the OS. You don't have to worry about any of that. You can make sure that it's highly available, and you can easily configure redundancy with these things. The benefit of a self-managed option in terms of the administration is you do have complete control over the entire system, which you don't with an AWS managed system. But the downside to that is that it does require some database administration expertise, and it does require the expertise of being able to set up and run these systems yourself. So there is a little bit of a downside there if you're going to be doing this on your own EC2 instance. As I say, version is quite important. So the version of Tableau Server that you have, depending on that version, you need a certain version of Postgres to be installed as well. It's worth pointing out that as of version 2020.3 and earlier, they are no longer supported as of November this year, because they used the older version of Postgres. So you can see over on the left-hand side there, the list of server version versus Postgres SQL version that comes baked into Tableau. Version 9.6 is no longer supported by the developers of Postgres, so Tableau have also retired the versions of Tableau Server that are relying on that version as well. As of 2020.4, Tableau moved over to version 12.2. The version 12 is now the major version, the 0.2 is the minor version, so as long as you are on a version which is the same as or greater than the version expected by Tableau Server, your repository should work fine. To be on the safe side, you might want to pick the exact same version that the server is expecting, that way you avoid any potential problems that might crop up from those minor release differences. But Tableau do recommend that you go with the latest version where possible, but it has to be at least the version that Tableau Server is expecting. It can't be any earlier. It's also worth making sure that when you're planning this and choosing which version you're going to go with, that you go and check Tableau's help page to keep up with the latest guidance and the latest updates from Tableau. As you can see there, this table is pulled directly from Tableau's help page, so I recommend you just go and have a look there if you're in any doubt as to which version you should pick. Scalability, again, all the benefits that you have with an AWS managed service, you can easily scale up and down with RDS and Aurora. You can choose which size of machine you want them to run, just as simple as changing an option. EC2, you also have the same available options. The only downside might be if you're running this in-house as opposed to on AWS. Scaling can be obviously a challenge, because if you're running a physical machine, that's a lot harder to scale up and down. Not really too much of consideration when we're looking at AWS. Scalability isn't really a problem whenever we're using anything in AWS, so that isn't really too much of a problem. Just something to bear in mind if you're building out lots of EC2 instances. You might need to configure all of them together, whereas if you've got an Aurora cluster, you can just kind of change them all at once. Redundancy is another obviously big consideration, especially when talking about the Postgres database. Your Tableau server relies on this process, so if it does drop, if it does fall over, you're potentially going to lose your server until you can get your database back up and running. So you can, with AWS managed options, the redundancy is going to be pretty good. You're going to have the options to set up lots of robust clusters. Directly within Aurora, you can set up as well a secondary node straight away when you're configuring it, so that it will automatically have that kind of failover without you having to do anything. So that's super straightforward. There can be a bit of sort of planning required. I mean, this applies to both, so it's not really necessarily a pro or con to either AWS or self-managed, but just planning out your redundancy so that it does actually work for you is definitely something that you want to take time to make sure you get right. Likewise, with the self-managed system, you can set up a very highly redundant system with, network load balancers and all that kind of stuff. But again, it just takes time and effort to make sure that it's working correctly. Make sure your network configurations are all set up correctly. Make sure all your EC2 instances are replicated correctly, and all that kind of thing. So the AWS-managed option here is simpler to set up, easier to manage, and generally will do the job. But if you're going to go and do this yourself on your own EC2 instances, there's a bit more a bit more work involved in getting it up and running. And lastly, cost is obviously a big consideration. The downside to the AWS managed stuff, pretty much the only downside to AWS managed systems is the cost. They are transparently billed, so you can see how much you're paying for each of these services. But RDS can get expensive, especially if you're using reserved instances. The bills can start to rack up pretty quickly. Aurora is a bit better than RDS. It's a bit cheaper, a bit more efficient. So that would be a better option in terms of the cost. But if you're going to go self-managed, it's going to be cheaper. But obviously, the downside to that is it requires more effort to manage. EC2 instances themselves are cheaper than running an RDS instance, but and yeah, PostgreSQL is free, which is always nice to have something that's free. So you can just install that, and you don't have to pay any license fees for the standalone installation. Not really the downside to the costs of running a self-managed system. It's going to be cheaper than AWS. It's just that administration overhead that is the real downside. So how does it actually work? How do we go about setting this up? So after you have installed your Tableau Server on your server machine, there are a couple of steps that you need to take when it's setting up the initial configuration, and this is where we need to specify our external repository. So the first thing to do after installing is set up the licensing and to register the product. After that, you get a page where you're going to put in your identity store settings, your gateway settings, and any other options that you need. And then in here, we have to take a step away from using the web interface if you're installing on a Windows server. If you're installing on Ubuntu or Linux, you have to do it all through the command line anyway, but the only way to set up an external repository is through the command line. So we have to use tsn commands to import some settings to set up the external repository. The settings that we have to set to import look like the JSON object that we have over there on the left hand side. We need to specify some information about the server, so that the Postgres server, so that the database, that the Tableau server can connect into the database. We need to tell it the flavor. The flavor is the type of external repository we're using, so whether it's RDS or a generic one. Generic is for a standalone non-AWS managed version. We need to give the master username and the master password, so this needs to be a super user on the database. We need to tell the host name, so what server it's actually looking for, and then the port on which it's going to communicate. The default for Postgres is 5432. Tableau recommend leaving it as the default unless there is a reason not to. And if you're installing straight from all the default settings in Tableau Server, that port will be fine. And then at that point we need to apply all of the settings once we've imported all of those, and then we can initialize the server. It's important that we don't initialize the server before we've set up the external repository, or it will go ahead and build an internal repository, which we do not want. So at this point I'm going to head over to my AWS console, and we are going to have a go at setting this up for real. So what I have in my EC2 instances here I'll hit refresh, make sure they're up and running. Yeah, so I've got 2 EC2 instances set up here, one of which is my Tableau server. So this first one here is my Tableau server that I have already started the process of installing the server on. We'll hop into that in a moment and have a look. And then my second EC2 instance here is just for my external repository. So all I've done on there is gone and installed Postgres database onto the server, make sure it's open to the world, so opened all the ports that it needs, disabled the Windows firewall so that doesn't get in the way, and opened up the listening addresses so that it's actually accepting traffic from across the network. These are both within the same subnet, so they can directly communicate to each other, and we can make that a private subnet as well, so that there is no external traffic that can come in. That way we don't necessarily have to configure SSL between the two. Tableau recommend that you do configure SSL between the 2 servers just for security's sake, and it is good practice to do that, but it is not required. So you can have unencrypted traffic between the 2. That's not a problem. For this example today, I'm not going to set up SSL, but all you need to do is copy these certificates across from one machine to the other, and then they should be able to communicate via SSL. There's some configuration required in Postgres to set that up, but there's full documentation on Tableau's website, as well as within the Postgres documentation for setting that up as well, if needed. So let's take a look at our 2 servers, shall we? So this is our Tableau server here, and this is our Postgres server here. So as I say, both of these are Windows servers. I think they're both Windows 2016, I think I set these up on, both running fine. So as I say, my Postgres database here, the only thing that's got installed is Postgres. I've installed version 12.6, as that is the exact version that Tableau expects. But as I say, any version after that should be fine, as I'm installing here Tableau Server, the latest version, which is 21.3.4. So what we can see in here is that my Tableau Server has been installed, or the first sort of step of setting up has been finished. The license has been activated already, so this activate stage has already been complete, and I've also registered the product. And what we have now is the setup stage, and this is where we need to bring in our different configurations to get our server up and running. So in here we've got identity store, we've got the run as service account, gateway, port, and a few other options as well that we can choose to enable or not. I'm not going to do any of this through the web interface, because if we do put our details in here and then hit initialize, that's going to fire up the server, whereas I want to actually set up my external repository first. So I'm just going to minimize that for now, and we're going to move over to our command line to set this up. What I have over here are a few config files that I've already set up with the necessary details to connect into my external database, as well as setting up my gateway configurations and my identity stores. So let me just open these up so that you can see what each of these look like. So my identity store, nice and simple. I'm just saying my identity store is going to be local, so I'm not going to be using Active Directory for this install. My gateway settings here, I'm just going to use the default settings essentially. My public host, which is not the same as this IP address because this is an old version, but this needs to be the IP address of the server, so I can just change these details over 18.133 and 165. No, 196 and 165. So that's the IP address of my server. That's the public address that people are going to connect into to get into my Tableau server. And I just, as well in here, just need to specify the port number and that kind of thing. Again, Tableau's documentation has all of this information of what needs to go into your JSON configs files to get them to go in correctly. And then lastly, I've got 2 different config files here, just to show you the difference between the 2, of which there is not much, for setting up the standalone repository. So if you're going to set one up in RDS, or in this case Aurora, as I have an Aurora database that this can connect into, all we need to do is tell it the flavor, which in this case is RDS, the master username, the master password for that database, and then we also want to put in here the host name for the server cluster, which in my case is this, and then the port that is going to connect over. Likewise for a standalone one, so this is then pointing to my Postgres database. I think I'll also need to change that host address, but it is essentially the same settings. The only real difference is that we need to tell it the flavor that it's going to be using, which in this case is generic rather than Postgres, rather than RDS, sorry. But again, same sort of settings, username, password, and address to connect to. Let me just pull this address and make sure it's the same. It is not, so 132.118 and 24. As I say, these are both in the same subnet, so they should be able to communicate with each other, no problem. So what I'm going to do is run some commands just to import my settings, and then we will have a look at getting it up and running. So what I've got here is I've moved my command prompt over to the directory which has got my TSM executable, so I can run my TSM commands from there, and I've got in here my settings that I need to import. My command's already up and running, ready to just copy and paste it in. I'm going to take my settings import for my ID store first of all, import those settings, do the same for the gateway, and then once they're both in, I'm going to run the TSM pending changes apply, and this will actually reconfigure the server even though it's not been installed yet. It basically adds those configs in so that it can use those when the server actually starts to initialize. Once that's completed, then I can go in and configure my repository. So there is another command for that. It's a separate command, so it's not a settings that we are importing. We are changing the actual topology of the server, so there's a TSM topology command for the external services. Within that is the repository, and we can enable that by pointing it to that JSON config file we looked at a moment ago. And here I'm specifying that there's no SSL between the two servers. If there were, you would have to give it a file path to the certificate file for the server that the repository is on. Okay, so let's run that command, and then it should give us a message saying that it has successfully linked the server. Yep, so the external repository has been configured successfully. It does again give us a warning here about our SSL not being up and running, but again we just need to be set a TSM pending changes to apply to actually apply those changes. And then once we've configured that, we can initialize the server and it will get up and running. It takes a moment for that to just apply, and then I will set off the initialize. While that's doing that, I'll just take a moment to talk about the alternatives to the EC2 instance that we have here. You can also set this up through RDS, as I mentioned, and if I just show you what I've set up earlier, and I did this with another server, I set up a Postgres repo in Aurora. So this is just a regional cluster within Aurora that's got two instances within it. It's got the writer instance, which is the primary one, and then the reader instance, which is the secondary. These have to be across two separate availability zones, so at that point you need to take consideration of the subnets that you have available, but you can set this up directly through the RDS create database menu. It's all very straightforward. You could just choose Aurora as the engine, and you can go ahead and set up all of the instances that you need to be up and running. And as I say, the only difference is that config file that we just need to point to the RDS database instead of to our EC2 instance. Okay, great. That has now finished configuring, so I'm just going to run my TSM initialize command to start the server. This will take a little while to run, so we probably won't see it complete, but it will then go off and start to initialize the server. Because we haven't done this through the web interface, we will also need to set up our initial Tableau Server user through the command line once it's up and running. We'll need to use tab command for that, so I have an installer down here to install tab command once the server is up and running. Once that's there, the server should then be ready to go, and we can go in and start to use it. So that is a quick introduction to how to get it up and running, and hopefully that has been useful. One last thing to mention before we close off this session. As of December 2021, this isn't quite ready to set up the Tableau server, but Aurora serverless is also available on AWS. This works the same way as Aurora, but you don't have to scale up the machine to match your requirements. It does it all for you. So you get all the benefits of using Aurora, but you only actually pay for what you use, not for a machine itself. The problem is that it at the moment only supports Postgres version 10. Tableau skipped that when they moved from 9 to 12, so it won't work at the minute for Tableau Server. But that doesn't mean that they won't introduce more versions down the line. They are also currently working on version 2 of Aurora Serverless, which is currently in preview, so you can go and check it out. But it doesn't even support Postgres yet. It's only on MySQL. But that may be one to watch over the next year or so. If they get version 2 out with Postgres, it might be worth testing that with your Tableau servers, your test environments, to see if that can help get all the benefits of the AWS-managed system, but without having to pay the big bucks that we currently have to do for the provisioned hardware. Thank you everybody for tuning in. Hopefully you've learned something. Hopefully that's been useful, and I hope to see you next time.